Hi students, today we are going to discuss carbon and compounds, TS 10th class 14th chapter. Right. So carbon and its compounds. So first we are going to learn regarding carbon. So what is a carbon atomic number? 6. Atomic number is 6. Its electronic configuration is 1s2, 2s2, 2p2. So in the valency shell, it is having a 4 valence electrons. 4 valence electrons. So due to this, it is required 4 electrons. So already it is having the 4 valence electrons. To attain the octet configuration, it is required the 4 electrons. Or it might be lose the 4 electrons. Means there is two chances. Its valency is equals to 4. So there is a chances of lose or gain. Gain means a negative charge, lose means a positive charge. So which is possible here? Either losing or gaining. So carbon having 6 electrons. Already it is having 6 electrons with 6 protons. 6 electrons with 6 protons. If it is lose that 4 electrons, if it is lose this 4 electrons, it is attain 2 electrons. Means this is the duplet configuration. Duplet configuration. So 6 protons with duplet configuration, it is not possible. The 6 electrons, 6 protons. ఈ 6 ప్రోటాన్స్ 6 ఎలక్ట్రాన్స్ మధ్యన అట్రాక్షన్స్ కానీ రిపల్షన్స్ కానీ న్యూట్రల్గా ఉన్నాయి. కానీ ప్రతి ఆటమ్ కూడా ఎప్పుడైనా స్టెబిలిటీకి వెళ్ళాలి అంటే ఆక్టేట్ కాన్ఫిగరేషన్ లేదా డూప్లెట్ కాన్ఫిగరేషన్కి వెళ్ళాం, అష్టక విన్యాసానికి వెళ్ళాం. సో దానికోసం ఇక్కడ ఒకవేళ తన వ్యాలెన్సీలో ఉన్నటువంటి 4 ఎలక్ట్రాన్స్ని ఒకవేళ లూజ్ అయితే దాని యొక్క కాన్ఫిగరేషన్ వచ్చేసి 1s2కి మారుతుంది. ఈ 1s2కి మారినప్పుడు ఇక్కడ ఉన్నటువంటి 6 ప్రోటాన్స్ ఈ 2 ఎలక్ట్రాన్స్ ని చాలా ఈజీగా హోల్డ్ చేయగలుగుతాయి. ద అట్రాక్షన్స్ మేబీ డామినేట్ దట్ 2 electrons. So atom cannot be exist. Okay? By losing, it is not possible. Maybe we can see with the gain of electrons. That 6 protons, the attractions with 6 electrons plus 4 electrons. The 6 electrons plus 4 electrons. So it is belongs to the neon configuration. It is belongs to the neon configuration. Means total 10 electrons with 6 proton. These attractions also might be not possible. But the gaining of energy is required more of gain of 4 electrons. Either single electron or 2 electrons, okay. But getting of 4 electrons, it is not possible to gain of 4 electrons. This condition also not possible by carbon atom. So the carbon will always try to the sharing of electrons. Sharing of electrons. So due to this, it will forms the covalent bonds. It will forms the covalent bonds. Right. So carbon, it is having the 4 valence electrons. So it is belongs to the 4th A group. It is belongs to the 4th A group or 14th group. It belongs to the 14th group. So its oxidation state is either +4 or -4. Means losing nature, gaining nature. If it is a lose that 4 valence electrons, it is getting a duplet configuration, but the atom cannot be existence. If it is gain of 4 electrons, then octet configuration it will reach. The 6 protons can 10 electrons. By gaining of that 4 electrons, it is required the more energy, but that nucleus cannot generate that energy level. So the atom cannot be exist here. So the carbon always that try to the sharing of that electrons to attain the octet configuration. So always it will forms the 4 bonds. Due to 4 valency, it will forms the 4 bonds. In this 4 bonds, there is a possibility of all the single bonds. The nature may be the all the single bonds are in the way of one double bond with the same atom or other atoms, 2 single bonds and 1 double bond. The another condition may be There is a one single bond, a triple bond with a similar atom, or a different atoms. Okay? Due to this four bonds nature, all the single bonds is possible, or maybe the double bond is possible, or maybe triple bond is possible. Okay. So due to this different types of the bond natures, the carbon can form the millions of the compounds. So that we are learning it's individually carbon and its compounds. So how the 4 valency? So here promotion of the electron will be done. In the ground state you can see that distribution of that electrons 2s to 2p2. In the s orbital it is a pair of electrons. In the p orbital it is two unpaired single electrons will be there and one vacant orbital. When it is trying to forming the bond formation to other elements, it will get its energy levels to promote that electron 1 s orbital to p orbital of pz electron. Then it will forms the 4 single electrons. Then it will show as the valency is 4. Actually, in the ground state, there is only 2 single electrons, so it will forms only 2 bonds. But it is getting the more stability. It is attained to the more stability itself. It will redistribute the energy levels to forms the 4 single electrons. In this, it will shows the hybridization. The involvement of the atomic orbitals can form the hybrid orbitals with an equal amount of energy and shape. Actually, nearly equal amount of energy orbitals can involve, redistribute and reshuffle into, they can form the equal number of new orbitals. Okay? Different energy level గా ఉన్నటువంటి atomic orbitals కలిసి ఈక్వల్ అమౌంట్ ఆఫ్ ఎనర్జీ అండ్ షేప్ ఉండే విధంగా ఒక న్యూ ఫార్మ్ ఆఫ్ ఆర్బిటాల్స్ ని ఫార్మ్ చేస్తారు. దట్ ఫార్మ్ ఆఫ్ హైబ్రిడ్ ఆర్బిటాల్స్ వి కెన్ సే యాజ్ ద హైబ్రిడ్ ఆర్బిటాల్స్. అంటే కొత్తగా ఫార్మ్ అయినటువంటి ఆర్బిటాల్స్ ని మనము హైబ్రిడ్ ఆర్బిటాల్స్ అంటాం. ఈ రకంగా జరిగేటువంటి ఆ ఫినామినాని హైబ్రిడైజేషన్ అంటాం. డిస్ట్రిబ్యూటెడ్ ఇంటూ ద ఈక్వల్ అమౌంట్ ఆఫ్ ఎనర్జీస్. సో ఈక్వల్ నెంబర్ ఆఫ్ న్యూ ఆర్బిటాల్స్ with identical properties with similar like energy and shapes. This phenomena is called as hybridization. సింపుల్ గా చెప్పాలి అంటే అటామిక్ ఆర్బిటాల్స్ అన్ని కూడా కలిసి ఆ ఎనర్జీ లెవెల్స్ ని ఈక్వల్ గా మార్చుకొని న్యూ ఆర్బిటాల్స్ ని ఫార్మ్ చేస్తాయి. దట్ న్యూ ఆర్బిటాల్స్ కెన్ బి కాల్డ్ as హైబ్రిడ్ ఆర్బిటాల్స్. ఈ హైబ్రిడ్ ఆర్బిటాల్స్ ఏ ఆర్బిటాల్ చూసినా ఎనర్జీ సేమ్ గా ఉంటుంది, షేప్ చూసినా సేమ్ గా ఉంటుంది. ఓకే, ఆ విధంగా ఫార్మేషన్ అవుతుంది. ఇలా ఫార్మేషన్ అవ్వడానికి కార్బన్ లో జరిగినటువంటి సిచ్యువేషన్ ఏంటి అంటే ప్రమోషన్ ఆఫ్ ఎలక్ట్రాన్. డ్యూ టు దిస్ ఇట్ ఈస్ ఫార్మింగ్ ద 4 single electrons. In the ground state actually it is only 2 electrons. Here only it will forms the 2 bonds. Due to this excited state, promotion of electron, it will shows the 4 single electrons. This can be involved into the 3 types of the hybridization. If the involvement of 1 s orbital, 3 p orbital, 1 s orbital, 3 p orbitals, that can be named as a sp3 hybridization. 1 s orbital, 2 p orbitals, that is a sp2. 1 s orbital, 1 p orbital, that is a sp hybridization. Means the carbon can shows the 3 types of the hybridization. Those are sp3, sp2, sp. So what is the sp3, sp2 and sp? So what is the examples and how can we how can we explain the term hybridizations? We can see now from the sp3 hybridization. So what is the sp3 hybridization? In the excited state of carbon, 1 s orbital and 3 p orbitals can intermix and reshuffle and they can form the new hybrid orbitals. So how many are intermixing here? 1 s orbital plus 3 p orbitals. So total 4 orbitals are intermixing. So 4 hybrid orbitals will be formed. 4 hybrid orbitals will be formed. So into 4 identical orbitals known as sp3 orbitals. That hybrid orbitals are can be named as sp3 hybrid orbitals. See the difference here. First it is s orbital and p orbital. But after intermixing and reshuffling, they can named as sp3. The name also it is a sp3 means it is nothing but it is having a similar energy and shapes. Previously it is a s orbital and p orbital. It is a spherical shape and it is a dumbbell shape. Different energy levels. But in the hybridization, it is converted into the sp3 orbitals. Right. So carbon it is a ground state. This is a configuration. The promotion of electron is done in the excited state. Then it will form the 4 single electrons. The involvement of 4 orbitals they can form the sp3 hybridization. As per atomic orbitals having how many single electrons in the respective orbitals, similarly it will followed by hybrid orbitals also. Means atomic orbitals now electrons how it is arranged. Similarly hybrid orbitals also having the same kind of the configuration. So that the four atomic orbitals having the four single electrons, hybrid orbitals also having each one a single electrons. Due to these four single unpaired electrons, might be it is bond with four different hydrogen atoms. This is with one hydrogen atom, and this is with one hydrogen, this is with one hydrogen, and this is with one hydrogen atom. And here, each hybrid orbital is forming with a bond with different atoms. So in the hybridization, only sigma bonds will form. Only sigma bonds will form. There is no pi bonds will form in the hybridization. Hybrid orbitals can only form the sigma bonds. So in this hybridization, sp3 hybrid orbitals can bond with the hydrogen atom. So hydrogen atom is nothing but its configuration is a 1s1. It is having a single electron. So this sp3 hybrid orbitals with a s electron. So it can be shown as sigma sp3 s bond. So each sp3 with one hydrogen. So like that, how many it will form? 4 it will be formed. So we can say as the 4 sigma bonds will form in the sp3 hybridization. So we are taking the major atom is carbon. The remaining atoms is hydrogen. So how it is geometrically it is arranged means the geometrical is tetrahedral. The bond angle between the two bonds is 109 degree 28 minutes. So this is regarding sp3 hybridizations. So once you can say this and note down. Now we can see sp2 hybridization. So how it will be formed? sp2 means one s orbital, two p orbitals, the reshuffle, and they can form the sp2 orbitals. They can form the sp2 orbitals. How many atomic orbitals are involving here? One s orbital, two p orbital. Total 3 atomic orbitals are involving. So it will form the 3 identical hybrid orbital. So it can be named as sp2 hybridization. Same general configuration and excited configuration, but here involvement of only 2 orbitals of p we are saying. So that up to 2 p orbitals, that is the sp2. Means in the carbon atom 3 hybridized orbitals, 1 unhybridized orbital will be there in the sp2 hybridization. So how it will be formed? The bonds. Each sp2 hybrid orbital of one carbon atom with another carbon atom of sp2 hybrid orbitals. It will form the one sigma bond. So total 3 sigma bonds. In this one already attached with one carbon of sp2 hybrid orbital. The next 2 hybrid orbitals will be there. These 2 hybrid orbitals with 2 different hydrogen atoms. You can see in the diagram. So carbon atom with another carbon, it will form the one sigma bond. The remaining 2 hybrid orbitals with 2 different hydrogen, 2 different carbons. First it will form the sigma bond with the hybrid orbitals. Then remaining 2 hybrid orbitals with 2 different hydrogen atoms. Then next, finally, there is a pz, unhybridized orbitals will be there. So it will bond with the next carbon, the another carbon of which is already paired of a hybrid orbital. The carbon atom already hybridized orbital with of another carbon, it is already formed the sigma bond. In this between 2 carbon atoms, that pz electron will be laterally overlap. Then it can form the pi bond. You can see in the diagram. This is the pz electron. So this is the pz electron of one carbon atom, and this is also pz electron. There is no possible of internuclear axis. Already that internuclear axis is done by hybrid orbital. So between the similar atoms, there is a next bond will be forming, that is only pi bond. See here, it is unhybridized orbital. So hybrid orbitals cannot form the pi bonds. It will form only sigma bonds. So due to this, we can say that geometry is trigonal planar, because as per the sp2 hybridization, trigonal planar. You can think this all the compound is only one. So one CH2 is in the above direction, one hydrogen and next hydrogen. So it is in the trigonal planar. So the bond angle is 120 degrees. So once check out this all again. So sp2 hybridization, one s orbital, 2 p orbitals, the reshuffle and their energies to convert into sp2 hybrid orbital with a 3 hybrid orbitals. The carbon in the excited state, don't forget to here, the pz is not involving, or only px and py is involving. So this hybrid orbitals having the 3 single electrons along with unhybridized pz. And the 4 electrons we have to write. So one hybrid orbital with another hybrid orbital of carbon atom, sigma bond. The remaining 2 hybrid orbitals with 2 different hydrogen atoms, so 2 sigma bonds. Unhybridized pz electron with unhybridized of another carbon of pz electron, that is a pi bond. But the carbon showing 1 sigma, 2 sigma with the 2 hydrogens and 1 pi bond. Total how many bonds here? 1 sigma, 2, 3 plus 1 pi. Similarly, another carbon also. See, sigma, 2 sigma, total 3 sigma. By the another carbon, extra 2 sigma bonds. Total how many sigma bonds here? 5 bonds plus 1 pi bond. So that I wrote here C2H4 molecule, 5 sigma bonds and 1 pi bond will be formed here. So this is a sp2 hybridization of a ethene molecule or ethylene molecule. Okay, in the examinations, if they asked only explain the sp2 hybridization, you can write the same scenario. If they asked, they given a direct molecule, the same you can write. Okay, so this is a sp2 hybridization. Just make it note, sp hybridization. So the example is C2H2 or ethine we can say. So how we can write? sp hybridization means one s orbital, one p orbital can reshuffle and they can intermix, they can form the sp hybrid orbital. So this we can call as a sp hybridization. Simple ga ela gurtu pettukovali ante, what is a hybridization is given that many atomic orbitals are involving. sp3 p3 అంటే 3 p orbitals, 1 s orbital. sp2 1 s orbital, 2 p orbitals. sp 1 s orbital, 1 p orbital. Right, coming to the configuration, sp3 అన్నప్పుడు ఏం చేసాం, all the 3 p orbitals we, right, sp2 2 p orbitals, sp అంటే 1 p orbital only intermixing, so that it is a sp hybridization. Each sp hybrid orbital having the each single electron, because atomic orbitals also having the single electrons. Right, coming to the explanation. So 2 hybrid orbitals, 2 unhybridized orbitals will be there. The total 4 bonds will be formed. So how the bond formation? Each carbon having the sp hybrid orbital, another carbon also having the sp hybrid orbital. First these two can overlap, they can form the sigma. Means the 2 carbon atoms are attached. That carbon having the sp hybrid orbital, the another sp hybrid orbital, this can be bond with the hydrogen atoms. The 2 carbons, 2 different hydrogen, that's a sigma bond will be formed. Carbon to carbon, 1 sigma, carbon to hydrogen, 1 sigma, the another carbon of hydrogen, 1 sigma. Total 3 sigma bonds are formed. Hybrid orbitals are completed. The remaining what? Unhybridized orbitals. So what are the unhybridized orbitals? 2 unhybridized orbitals, that is py and pz, of a carbon atom and their carbon atom. They can laterally overlap, the sidewise overlapping, they can form the pi bonds. So you can see in the diagram. So py orbital of another py, they can form the pi bond. Pz orbital, they can overlap, they can form the pi bond. Means there is no possibility of internuclear axis. If one it is formed as an internuclear axis, there is a possibility of the only sidewise overlapping. So between the 2 similar or dissimilar atoms, there is a possibility of only 1 sigma. After that, the second bond formations, those are probable to the only pi bond formation. So in the C2H2 molecules, 3 sigma bonds, 2 pi bonds. This pi bonds caused by py orbital and pz orbital. This 3 sigma bonds by 2 hybrid orbitals with a carbon to carbon and 2 different hydrogen atoms. You can see here, carbon 1 sigma with a hydrogen, the another carbon with a hydrogen, this is sigma. Carbon to carbon first bond is sigma bond. Py and pz orbitals can form the pi bonds. So it is in the geometry is a straight line. So that is a linear geometry. Linear is nothing but 180 degrees bond angle. So this is the C2H2 formation or simply sp hybridization. So please make it note. Allotropes of carbon. So what is the allotropes of carbon means? The element exists in two or more physical forms. Right? We are studying with carbon. So the carbon can exist in 2 or more physical. It is having the same chemical properties, but different physical properties. So what we are seeing, this element having different physical properties, similar chemical properties. So which element shows different physical properties but similar chemical properties, that we can say as the allotropy. So that forms can be called as allotropes of a carbon. So we can classify these allotropes of a carbons into two types. One is amorphous, another one is crystalline. Amorphous and crystalline. So which are not having the particular shape or geometry. Okay? There is no particular geometry. There is not fixed arrangement of the carbon atoms. So that we can say as the amorphous allotropes. Example is coal tar, coal gas, gas carbon. So this all will belongs to the amorphous forms. Crystalline forms, which are having the particular geometry, it is systematic arrangement between the carbon atoms in that particular arrangement, that we can say as the crystalline forms. Example of diamond, graphite, fullerenes, nanotubes. So these four are the crystalline forms of carbon. So which are having the particular geometry, those can be say as crystalline forms. Which are not particular geometry, that is amorphous forms. How it is arranged, the diamond how it is arranged, the graphite how it is arranged, that we can see now. So next diamond. So in this there is a hybridization. The bonds between carbon to carbon, the hybridization is sp3, and the arrangement of diamond, the carbons how it is arranged in the diamond means this is a lattice structures. So it is a critical angle. If it is any light surface in that surface area, it will give a more brightness with a bond angle of this reflecting angle of 2.42, and it is a structure. Geometry is a tetrahedral, and it is very hardest substance because of higher attraction forces between the carbon to carbon. So it is very hardest substance. And next, it is a very bad conductor of electricity because of there is no pi electrons, means a free of electrons is not there in the diamond. So it is very bad conductor of electricity. Where we can use, so we can use it into the jewelry, that means ornaments we can use, and we can use it into the cutting of glasses. So this is regarding a diamond. Coming to the graphite. In the graphite, it is hybridization is sp2. The carbon can be involved into the sp2 hybridization. Means there is a unpaired of electron will be there. That can act as a mobile electron. Due to this mobile electron, the graphite conduct the electricity. As a non-metal, it will conduct the electricity due to mobile electron. Or simply we can say free of electron. Right. This graphite having the layer forms. There is no stronger attraction, so it is having the layer forms. Due to layer forms easily returnable by using of pencils, already we know we can write easily, and it is having the smooth nature, and it can be easily erasable due to that delocalized pi electron, means that due to pi electron, the free of electron easily erasable. Due to simply we can say the weaker dispersion forces between the carbon to carbon or layer to layer, so it can be easily breakable by using a force of eraser. It can be easily erasable in a paper. So this is regarding a graphite. Next allotrope form of a carbon is a Buckminster fullerene. So it is an example. We can take the C60. There is a C90 also possible, but here we can discuss the C60. It is in the shape of a saucer ball. So in this there is a, for example, you can take this ball. So it is having rings. When you cleanly observe, there is a possibility of this kind of the ring formations. Okay, when you see that particularly, it is having the pentagonal or hexagonal will be possible. So how many pentagonal and how many hexagonal rings will present in the C60 means 20 hexagonal and 12 pentagonal structures will be there. And it is a hybridization of sp2. And next, uses. This fullerenes can be used into the targeted bacteria cells. Okay, in our body where the bacteria will be present, that we how to remove. For that, this fullerenes we can inject, then we can treatment of that bacteria cells. Maximum they can use into the target of cancer cells. Example, melanoma. The fullerenes which are present in the spherical shape, those can be called as bucky balls. So this is regarding fullerene. The another form of allotrope is nanotubes. It can be discovered by Sumio Lechima in 1991. These are actually compared to the graphite. Graphite is in a thin sheets, okay, in the form of a sheets, but these are arranged in a cylindrical shape, so that this we can say as the nanotubes. This particularly used into the integrated systems to get the more information instead of copper wires. Okay, it can be passed as an electric current. Right, insert biomolecules to the targeted single cell. Only particular single cell can attack shell. Right? There I have to give the treatment. So first we have to send the nanotube, then we have to inject the biomolecules. So this is the use of nanotubes. These are all allotropic form of the carbon. So allotrope forms of the carbon actually classified into the two types. One is the amorphous and crystalline. Amorphous is a coal that which are not in particular geometry. Those are considered to the amorphous forms. Crystalline forms which are having the particular geometry, the systematic arrangement of the carbon atoms. So in that we discussed diamond, graphite, fullerenes, nanotubes. Okay, these are all very important. Either maybe they will ask into the differences, right? The differences between diamond and graphite, or what are the uses of nanotubes, or what are the uses of fullerenes. These are the important questions from this topic. Okay.